Okay, so I'm going to set up the machine just on this board here. So this is it's just a whiteboard. You can use big surfaces, you can use small surfaces. This is big enough that you get an idea of the scale and the speed of the machine. So what I'm going to do is take one of my motor mounts. Lots of different ways of actually fastening on these. This is deliberately left undersided, so if you're putting this in a permanent fixture, you just pop some screws through there. I think I would still recommend using some sort of foam backing or something for it, just to deaden the vibration a little bit, because the sound of the motors does feed directly through the bracket. So what I've tended to do is use a bit of adhesive foam. So I use this stuff, which is you get it. It's just called sticky fixer here, but it's just double-sided kind of foam adhesive. It's fearfully sticky, so if you do stick it to anything, it's difficult to pull it back off without damaging the surface that you stuck it to. Temporary exhibitions, what I tend to use is these command strips. So they're pretty good, so they're good and sticky for smooth surfaces, so you can stick them on windows and things with this. Now these are very, very expensive for what they are, and so I don't use them all the time. What I'm going to do is just put two on there, I'll put one across the top there, I think, as well. So I've just stuck those on there. Peel them off. I'm just going to put that in the top corner. I'm going to line it up with the frame here, so I don't really have to worry about making this square. I'll just do the next one. Now these are both the same as well, they're not handed. There's that. A couple of these little cactus parts. Just hook on. And a sec. See that okay? And the motor's just hook on like so. Good. So there's three measurements that we need to do, and I've worked them out here. So the width is 760 millimeters in this particular one. So that if you measure the shortest distance between the edges of the sprockets, that's the kind of the tangents of the sprockets. So I've got one there, I've got one there. It's this distance here. That's width. By coincidence, this is the sprocket, and this is also the top edge of the machine. So this is a line which goes in between the shafts of the motors. So that's the width. We have height. And then there's a home point. So the home point I've measured out here, this is half of the machine size across, and it's 120 millimeters from the top. So the home point is 380 to 120, and that will go into the controller. The width is 760, the height is 1100. All of those measurements are also in the worksheet as well. So this is a diagram which shows all those things. And make a note of machine width, machine height, home point distance from left edge and also from the left edge. And that's what those coordinates are. So what's next? I'm just going to tidy this up a little bit and mark some of the lines on more permanently. I've made a note of these numbers elsewhere. Okay, next up we're going to string up the gondola. The beaded cord just sort of snaps into the arms there. That loops on the top. We've already filled the little counterweight bags with something heavy. This is just some nails and nuts and bolts and things that I have lying around. And you can move that gondola anywhere in that space. Little box here. I've got the motors connecting to the top there. We've got this other connector here, which is for the pen lift. So the pen lift is fastened on to this one like here. So this goes together. There's two different coloured sets of wires here. The yellow on the motor and the white on the extension, or the signal cables. So there's a little arrow on the connection for the servo motor on the Polagraph machine here, which indicates which one is the signal pin. So that's the white wire aligned with that. So let's apply some power. Okay, so it's all up. It automatically raises the pen, so the little control horns poke out there. So if there's a pen in there, it would be off the page. I'll do something here to test the motors. So you probably see a little wriggle that it does there, which just means that that's now locked. So those, I can't really pull on those. I can't pull if I really want to. But if I'm going to move it, it's easy just to take a little bit of weight off it. Or even to turn them by hand. So what I've done there is lined that up over the home point there. So the home point is directly underneath this pen. If I put a pen through there right now, will fit this one. Just the tips of the pen. Pen there, and I drop that, and it would put a mark directly on the home point. So this is where we need to be. This is how the machine starts. Once you've set everything up, you've plugged your machine spec into the controller. On the controller, you've done a upload machine spec, and that uploads the machine spec to here, and it becomes saved in there as well. So when you reset it, you don't need to do that again. The only thing that isn't retained in that is the pen width. So pen width you always need to set if you're going to use that. Pen width is really important if you're using a shaded kind of pixel style. If you're doing vector drawings, it doesn't make any difference whatsoever. You can lift the pen or drop the pen just using pen up and pen down. All of these commands you can also send via the controller if you need to, if you don't have access to this. But this is normally how I would set it up. Is move the machine to the, or move the conduit to the home point, turn the motors on, fit the pen. I've already connected by this point, so I go to the software and I do a set home command, which says, right, okay, now the machine's, you know where the pen is, and after that point, I can move it where I want to, because it knows where it is. Unless something goes wrong, the two will always stay in sync.